Hi guys, good morning. So today we'll be starting with the switching and related to switching, the topics that you have studied is VTP, VTP, STP, VLAN. Next, okay, inter VLAN, routing, then FHRP, then hmm, HSRP. In FHRP, you studied HSRP, right? Yeah. Okay. Okay. Also VRRP you studied. Okay, you studied VLBP also, or just the name. Hmm? Did you study about the GLBP protocol? No, just the name, right? Practically, you have studied, I believe, only HSI. Correct? Okay. What else? What else? That's it. Ether channel. And the Ether channel, what are the protocols did you study? Everybody's done? Hmm? And the Ether channel. Okay. Two protocols you study. LACP. Then, and did you study the static mode also? Static Ether channel? Yes or no? Studied? No idea. No? Studied but okay. Just tell me the meaning of this thing. Studied but basic. You can get a chair from there. One student can come here. I think we have two seats already, right? Yes. Studied but basic. What does it mean? Hmm? Means just the name? That's it? Okay. What else? Any other topic you studied? Because you're missing a very important topic. Port security. Okay. Good. How many of you are in the CCA security? 1, 2, 3, 4, 5. Security people forgot security, huh? Okay. Other than port security, what else? CCNP. We are studying CCNP, right? So, anything else? Not BPUD guard, it's BPDU guard, right? But that is under ST2, right? Done. What else?
DHCP snooping.
Good. DHCP? No thing.
Okay.
Relay agent. In relay agent, is there any role of switch? No. No role of switch, right? Okay. Then what else? One more topic. Multi-layer switch. So then why you didn't tell me about switch only? About switch, multi-layer switch, anything else? Hmm? Still one more important topic is missing. SVI. What is SVI? Sub-interface VLAN. R things. What you're missing is dynamic R things. Okay. So how good you are in these topics? Just tell me. Today is CCNA revision for switching. Tomorrow onwards we'll start switching. So tell me how good you are in these topics. How confident? Okay. How many of you are confident 80%? First of all, let's go with 100% that, okay, I know all the topic. Anyone? No one. What about 90%? 90% sure that, okay, I can answer all the questions. 80, 70, okay, 1, 60, again 1, 50, so many. Okay. How long back you had your CCNA? Month back. Week ago. A week ago and you forgot everything. 1.5 months. So you had your outcome or something in between. Yes. Okay, still more students. Many. Okay. Okay. Sure, sure. Guys, please wait a moment. We'll take it. Please. Okay, so these are the topics that you study in your CCNA. And I see most of you are saying that, okay, only 50% confident, right? So let's revise all these topics. First of all, switch. What do you know about a switch? Mm-hmm. And okay. About a switch, you say it's a L2 device, right? Okay. What else? Intelligent device. How? Stores MAC address, virtual MAC address. Works on MAC address. Okay. So your MAC address, you can say MAC address or hardware address. So why it uses MAC address or how it works on the basis of MAC address? Interface. What about interface? How a switch works on the basis of MAC address? Forward message based on the which MAC address? Destination MAC address. So instead of saying uses MAC address, what do you say? Makes forwarding decision based on destination MAC address. Okay. Rather than saying this uses MAC address, you will say what? Makes forwarding decision based on destination MAC address. Because switch is going to forward a frame based on destination MAC address. Is that clear? Okay. So I'll say here makes forwarding decision based on destination MAC address. This is how you explain your intelligent device. Because switch is able to store MAC addresses where? MAC address table. And where that MAC address table is stored? CAM table. Where is it stored? You know your MAC address table, right? Also known as CAM table. What is CAM? Content addressable memory. So this is a memory where the table is stored, where the information is stored. That's why it is also known as CAM table. Stored in the CAM. Is that clear? Okay. What else? What else about a switch?
So we can separate the network using VLAN
Okay.
and can connect multiple devices.
Right now we are going with the introduction to switch only, not with the VLANs. Okay. Okay. So you are saying per port collision domain. What do you mean by per port collision domain? Collision can only occur on a specific port. Okay. So will there be a collision on the switch? No. There can be, but less chances. How do you explain that? No, that is a different thing. Full duplex is a different case. How do you explain per port collision domain? Hmm? Okay. What is collision domain? It's a part of a network. May happen. Right? What is your answer? May happen. Then how you can say that okay, collision will happen on a particular port? At one point you are saying that okay, collision may happen. There is a possibility for collision. And in another definition, you are telling me that okay, collision will happen on a particular port. Conflicting, right? So how do you explain that? Explain it to me. So collision domain is right? It's a part of network or either a network. Can be a network or part of network. Where there's a possibility for collision. But in what case? In what case there is a possibility for collision?
Sir, there is a lot of disturbance. We are not able to hear you clearly.
A lot of disturbance. Guys, everybody is facing the disturbance online.
Yes, sir.
Your
voice is breaking.
Nice, I guess. Is it like voice breaking or?
So there's a lag in your voice.
Okay, that could be internet issue. There was a lag coming. Just give me a moment.
Sir, this is the SD-WAN class of advanced switching.
This is switching batch, not SD-WAN.
Okay. So who is taking the SD-WAN class?
SD-WAN, you should join Nikunj.
Okay.
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 Yeah. Is the voice clear now? I believe internet.
Yes.
Okay. So about full duplex we were discussing, right? That full duplex is what? Possibility for collision. But in what case? In the same direction. If the road is one way, is there a possibility for an accident? No, right? So that means it has to be two-way communication. Two-way communication. And when there is a two-way communication, that means two devices are there who are transmitting the information at the same time. So whenever you explain your collision domain, how do you explain it? You say it's a network or part of network where there's a possibility for collision. There's a possibility for collision when two or more nodes are communicating simultaneously or at the same time. If the communication is one way, there is no possibility for collision. Clear? Okay. Now we say that, okay, there's a possibility for collision when two or more nodes are communicating at the same time. Correct? Then what is port collision domain? And when two devices are communicating simultaneously, you know that switch is a full duplex device. What is full duplex? Possible. Two devices, two nodes can communicate simultaneously, right? So that means if two devices are able to communicate simultaneously, will there be a collision? Highways, right? Separate ways to go and separate ways to come. Is there a chance for collision? Yes or no? Maybe. How? There is no overtaking concept here. Right? So here, the collision is possible, may happen because of either electrical failure or mechanical failure. The collision is possible because of electrical failure or mechanical failure. So if a collision happens due to any electrical failure or mechanical failure, if the collision happens due to an electrical or mechanical or XYZ any reason, only a single port will go down. On a switch, only a single port will go down, not the entire switch. What happens in the case of hub? If there is, because single collision domain, right? Only one way to go or come, right? Only one way to pass the information. So if a collision is happening, the path is blocked. Nobody is going to have a communication. That's why the entire hub goes down, because single collision domain. Is that clear? So now you understand port collision domain. Okay, what else? Single broadcast domain. Now what is broadcast domain? That is broadcast. What is broadcast? You say one-to-all communication. So right now, here I'm delivering some information. What type of communication? Broadcast, one-to-all. But when you say one-to-all, there is still a limitation. There is still a limitation, because there is something that limits the broadcast also. In our case, this classroom, boundary. This is the boundary of our broadcast. Anybody outside or in another classroom, they won't hear this. Right? One to, that is multicast. One to many, you can say, when I'm delivering the information only to these people. When you're communicating with more than one, but you're not communicating with everyone. That is multicast. But right now, everybody in our classroom is listening to it, right? So this classroom is the boundary of our broadcast masses. So of this entire building, this is the part where my broadcast message is reaching. So how do you explain a broadcast domain? Broadcast domain is the network or part of network where a broadcast message can travel. That's it. A broadcast message never leaves a broadcast domain. Never goes out of a broadcast domain. Remains within a broadcast domain. Is that clear? So switch does not divide broadcast domain by default. By default, switch does not divide the broadcast domain. And that is the reason switch is what? A single broadcast domain. That means all ports of the switch belongs to the same broadcast domain. And when you say same broadcast domain, what does it mean? It means if there is any broadcast message on a port of a switch. If there is any broadcast message on a port of a switch, that message is going to travel through all the ports of the switch. That means if we take an example here, this is a switch. Okay, has some ports. Say this is a switch. Okay. Now, if we consider that, okay, there is a broadcast on this port. Maybe a PC generated a broadcast, right? So that message is going to travel through all the ports. Everybody connected to all these ports is going to receive that broadcast message. This is what a single broadcast domain is. Is that clear? So how switch deals with the broadcast message? Tell me. Except the port it was received on. How a switch deals with the broadcast message? Switch floods the message through all the ports except the port it was received on. So that means it was received on this port, right? So switch did not send it again here. Yeah. This is how a switch deals with the broadcast message. Clear? Okay. Online people clear?
Yes, sir.
Okay. Now, after switch, you studied about VLANs. Now, what is a VLAN? Virtual interface used to get the used to divide the broadcast domain of a switch. But why would you want to divide the broadcast domain of a switch? So I can use a different switch itself. I can use a, okay. Now this question. Good statement. You said to divide the network, right? So tell me one thing. I'll use some PCs here. I have 4 PCs. This is your switch. PC1, PC2, PC3. This is PC4. Okay. So what I'll do is, let's say I'll use 10.1.1.1. Here I'll use 10.1.1.2. Here I'll use, let's say, for example, 1.1. Now here, if I try to communicate from PC1 to PC2, will I have communication? PC1 to PC2? Communication will be there? Okay. What about PC3 to PC4? Communication will be there? What about PC1 to PC3? Will communicate or will not communicate? Okay, how many of you are saying will communicate? 1, 2, 3, 4, 5, 6, 7. And how many of you are telling that will not communicate? 1 will communicate or will not communicate? Will communicate. Why? Broadcast domain. Okay. So if I try to ping from PC1 to PC4, will I ping? Yes or no? Yes. Yes. Okay. Yes. Okay. Now tell me, when you define a router, what is a router? To connect define a switch, and you are telling will communicate. How do you define a router? Provides communication between different networks, right? Routes the traffic between different network or from one network to another network. But here there is no router, and you're telling they will communicate. So, will communicate or will not communicate? Hmm? Will not communicate. Why?
Sir, we can communicate because switch work in same network.
No, PC1 to PC4. PC1 to PC4. Both are in different network. Correct? Will communicate or will not communicate?
We can make it to communicate provided we make the switch as an L3 switch.
No, as of now, it is L2 only.
In L2, we cannot.
Okay. So you say that okay, they will communicate or will not communicate. Not hearing. That is too loud. Will communicate with the help of VLAN. So how? Will communicate or will not communicate? Will communicate. Because see, another point. Switch works on the basis of MAC address. There is no role of IP address. Now tell me, will communicate or will not communicate? But two different networks cannot communicate without a router. Now tell me, will communicate or will not communicate? Why? If packet is going, why PC4 will reject? Hmm? No idea. Not communicate. Why? I just want to answer why they will not communicate. Will communicate or not? Because you were telling to divide the network, you use VLAN. I already divided the networks without a VLAN. So what do you think? Will communicate or not? Okay, raise the hand. How many of you think will communicate? No. Okay, how many of you think will not communicate? A lot of confusion. Think about it. The answer is they will not communicate. First off, they will not communicate. Why? Because you are just focusing on the switch and the router MAC address and IP address. If you think about default gateway, no? What about default gateway? Today we'll have to go like this only. Huh? Yeah, that's what I'm telling. Today we'll have to go like this only. Okay. So what about default gateway? So is there any role of default gateway? What is the role? If PC1 wants to communicate with a different network, PC1 requires what? Right? And what is default gateway? Generally the router's IP. Is there any router? So PC1 itself will drop the packet. How they will communicate? PC itself will drop the packet here. Yes, any doubt? No? Is it clear why they will not communicate? Because default gateway is required here. And default gateway is what? Router's IP address. Default gateway is what? Router's IP address. Is there any router here? No. If there is no router, no default gateway. Without default gateway, a PC cannot send packets to a different network. Clear? Second thing, PC1, PC2 in the same network, PC3, PC4 in the same network. So PC1 will communicate with PC2 and PC3 will communicate with PC4. Two networks are divided without a VLAN. Then why VLAN?
Sir, if a switch receives a broadcast, it will cut to all the roads. That's why it relay traffic.
Point number one is that if there is any broadcast, the switch will forward it where? Broadcast traffic is going everywhere. First problem. What else? That's why you divide the broadcast domain, right? To limit the broadcast. To limit the broadcast. But any other reason? Only one reason that you want to divide the broadcast domain. That's why you create the VLANs.
Sir, normally while pinging ICMP request and ARP request will generate. I don't know where it is pop.
Sorry.
That's the chance for while pinging ARP request and ICMP request will be generated from.
Yes.
But it will be chance for dropping. I don't know where it is dropping.
Okay, you don't know where it is dropping.
Yes.
See, ARP is a broadcast. So ARP will go everywhere. But again, to communicate with a different network, default gateway is required. Right? So without default gateway, there is no communication at all. So first reason is you want to divide the broadcast domain. Because the broadcast message is reaching in all the networks. First problem. Second problem. What if this guy, PC number 3, he changes his IP to something like, now what? It is going to communicate with the PC1 and PC2. Or what if from PC1 and PC2 somebody changes the IP to something like, they will communicate. Security issue. Right? A bit of security is also provided. But I'll say, why do you want to connect two different networks to the same switch? To reduce the cost. Okay. Two benefits are there. One is reduce cost. Okay. And also hardware requirements. Because less number of cables, less number of switches will be required. If I have multiple departments in my organization, but the number of devices or the number of nodes in each department is just like 5, 10, something like this. So I can use a single switch. Yes. Sure. Guys, please wait for a moment. And also, why we are connecting? Because there are less number of nodes in our each department. So rather than purchasing a individual switch for a department, we just go with a single switch. And to maintain the security and to maintain the segregation of the traffic, we use VLANs. Here. Okay.
Now with VLAN, you do not have communication, even if they are in the same network. Like if I divide VLANs for an example, let's say this is one department, this is another department. Now what will happen? Say this is the HR department and this is our sales department. So if there is any broadcast on the HR department, that will remain within the HR department only, will not travel to PC3 and PC4. And if there is any broadcast on this side, that will remain within this broadcast domain only. And PC1 and 2 will communicate, PC3 and 4 will communicate. There will be no communication at all between the two departments. And now, even if these people, they change the IP addresses, let's say this guy changes to 172.16.1.3. Okay. And this guy changes to, let's say, 10.1.1.3. They won't communicate, even if they are in the same network. Okay. And even though they have the default gateway also, still they will not communicate. Okay. Until or unless you are using inter-VLAN routing. Okay. Without inter-VLAN routing or with inter-VLAN routing. With inter-VLAN routing, definitely two VLANs will communicate. But without inter-VLAN routing, they won't communicate even if they are in the same network. Like as of now, I don't have a router. Okay. I don't have a router, but still PC2 and PC3 will not communicate, even if they are in the same network. Why? Because when you try to ping from PC2 to PC3, PC2 will generate an ARP. ARP is a broadcast, and broadcast will remain within the broadcast domain only. That means on the HR side only, it will not travel on the sales side. And if the ARP will not travel, will not get the MAC address, there will be no communication at all. There will be packet drop. Why? Why the packet drop? How do you technically explain that? Consider this thing. Sorry. Destination host unreachable. Let's say this here IP address is 10.1.1.3. Now I go to PC2 and I type in ping 10.1.1.3. We know that they will not communicate. Why? Two different VLANs. Okay. And for the first time, PC2 will generate one ICMP and a ARP. So first of all, ARP will travel to fetch the MAC address. Correct? Are we going to get the MAC address? No, we are not going to get the MAC address. Why? The broadcast, the ARP will never reach PC3. So if the broadcast will not reach the PC3, there is no coming back of MAC address. And that situation will be known as, because packet will drop due to incomplete information. Right? So this situation will be known as what? Encapsulation failure. So why the packet drop? Due to encapsulation failure. I believe everybody understand encapsulation, right? Yes or no? What is encapsulation? Encrypt. Adding MAC address. Okay. Okay, tell me about these terms. Encapsulation. Decapsulation. Encryption. Decryption. So what is encapsulation? You guys are telling me, so I'm asking. Additional data, adders, not in trailers. Both. What is encapsulation? Encapsulation is adding an extra information in the front and back of a packet. Okay, or data, or you can say, what do you call that? Data unit, right? So when you're adding some extra information, that is encapsulation. And the reverse of encapsulation is decapsulation or de-encapsulation. Both are the same. Decapsulation or de-encapsulation. What is encryption? Converting data into ciphertext or changing human readable data into scrambled text, readable to unreadable form. Correct? And what is decryption? Reverse, unreadable to readable, ciphertext to plain text. Okay, that is decryption. Okay, at which layer encapsulation happens? At which layer of OSI encapsulation happens? Layer 7 to layer 1. 4. Any layer where extra information is being attached, encapsulation is happening, right? And at which layer encryption happens? Encryption takes place in the presentation layer. Takes place in the presentation layer. Is that clear? Okay. So this is clear. So VLAN is what? What is a VLAN? Define VLAN. How would you define? Anyone? Now we have discussed a lot of things about VLAN. So define VLAN.
Sir, we can say VLAN is a way to divide a network into a smaller group.
Again, I will say we can use subnets to divide the network. Of a switch. Okay. VLAN, how you can start is VLAN stands for virtual local area network. It's a way to divide the broadcast domain of a switch or convert a switch from single broadcast domain to multiple broadcast domain. Okay. Then you can say each VLAN is a broadcast domain. Each VLAN is a broadcast domain. Okay. So why switch is a single broadcast domain by default? Because all ports of the switch belongs to a single VLAN. And that VLAN is known as default VLAN. VLAN 1. Your default VLAN. So all ports belong to the same VLAN. All ports are the member of the same VLAN. That's why single broadcast domain. As soon as you create VLANs and add some ports into it, the number of broadcast domain changes. Is that clear? Yes or no? Okay. So how many VLANs are there? How many VLANs are there? 4096 VLANs are there. These many VLANs are there? Okay. Range is 0 to 4095. This is the range of VLANs. Correct? Any reservations? 0 and 4095. These are reserved. Why? Native VLAN, VMware and AppleTalk. Okay. Right now, let's go with reserved only. Okay, because I'll explain it later for what they are reserved. Okay, are they visible in the switches? They are not visible in the switches, and you cannot use them in the switches. They cannot be created, modified, or deleted. Is that clear? So you can simply say cannot be used in switches. Yeah. Okay, what about VLAN 1?
It's a default VLAN.
Default VLAN. Why it's a default VLAN?
All ports are
By default, all the ports are member of VLAN 1. Okay. All ports of a switch are by default member of VLAN. You cannot delete this VLAN. You cannot delete this VLAN. This will remain in the switch. Okay. Then what next? 1002 to 1005. Directly 1002 to 1005.
1001.
Where are in between VLANs? VLAN 2 to 1000. Where are those? Those you can create. Those you can create, right? So VLAN 2 to 1001. These are what? Standard range of VLAN. Okay. You can create them, modify them, and delete them. Clear? Can be created, modified, and delete. Because we are creating them, we can also delete them. Thousand two to 1005. These are legacy. What do you mean by legacy? Just cram the word, huh? This is correct. These are legacy VLANs. These are legacy VLANs. So these VLANs, they were used in FDDI and token ring networks, older technologies. Okay. But now you cannot use them. Where is the mic? No problem. Oh. Okay. Then next. 1006. 1006 to 4095. These are 4 or 5. Why 4? Because 4095 is already reserved. Okay. Only one person pays attention. Okay. So these are what? Extended range of VLANs. Okay. But these are not supported on all the switches. Why? There is a condition here. Because these are allowed if the switch supports VTP version 3. If your switch supports VTP protocol version number 3, then you can use them. Otherwise, you cannot. Yep. Not it. Okay. So all these topics you have studied in your CCNA, right? But not in quite detail. So in this switching batch, we will study all these things in the detail. This is clear. Now, when it comes to switching, okay, so switching is part of your ENCODE book. You know, right? We have 2 books. CCNP ENCODE and then CCNP. Right? This is majorly about routing. Okay, this is majorly about routing. And this has some part of switching also. So in your ENCODE book, we have total of 5 chapters related to switching. Related to switching. Chapter 1 to 5. Okay, so those are chapters we will be discussing. So let me walk you through all the chapters, what all the things are there. Okay. See here, this is the book. Okay, CCNP and CCI Enterprise. So here we have these 5 chapters. Number 1 is packet forwarding. Then we have STP, advanced STP, MSTP. Then we have trunking and ether channel. Then after all about L3, routing, services, overlay, wireless. These are the topics. So chapter 1 to chapter 5. These are the chapters we are going to discuss. Okay. So under these chapters, what all the topics are there? Okay, so if I show you the topics, some of the chapters are topics are optional. I have already mentioned here. So first one is about packet forwarding and packet flow. Then basics of switch. So in switch basics, fundamentals of L2, addresses, collision domain, broadcast domain, what we have discussed today. Then we'll start with what is MAC address table, how your switch learns the MAC address, populates the MAC address table, right? Then after, we will talk about VLANs. A brief introduction today I have already given you, okay? But still we will be discussing all the things again, okay? So make sure to revise the switching part from your CCNA. Okay, so we'll talk about switch port modes, DTP, tagging, native VLAN, what is allowed or blocked VLANs, range of VLANs, VTP, inter-VLAN routing, all these topics. Then after STP is there, because related to STP, you can see we have STP, advanced STP, and MST. 3 chapters just for spanning tree only. You can understand how important protocol this is. Okay, so STP we are going to discuss. So again, CST, PVST, PVST plus, STP protection mechanisms like, BPDU guard, BPDU filter, and all those topics, RSTP and MST. Then after we'll come to Ether channel. Okay, so under Ether channel, we will talk about L2 also, L3 also. We'll see LACP, PLGP, and starting method. Okay, then FHRP we will discuss. So HSRP and VRRP practically we will see. GLBP we are not going to see, part of CCI enterprise. Okay. Then after L2 security, so your port security mechanisms, dynamic ARP inspection, DHCP snooping, all these methods we are going to see here. Then we will also see about VLAN ACLs. Okay. Then optional topics are there. If we have time, I will definitely discuss them. What are these? How do you configure them? Okay, like what is private VLAN, and then what is switch port analyzer. So these are the topics that are present in your switch. So make sure, like tomorrow onwards, again, we will go with the basics only related to VLANs and switch. So task for you is tomorrow you will come up, you will prepare first of all about how switch learns the MAC address. Okay, how switch learns MAC address. This is just one question I'm giving you. You guys can prepare it. So tomorrow you must know how switch populates the MAC address table. Clear? Okay. Online people clear?
Yes, sir. Yes, sir.
Okay. Now,
Yes.
offline, everybody has submitted the details. I think everybody will submit, offline and online, everybody will submit this form. And give this to the guy who has not submitted. Submit your details. Here. Because your drive access will be according to this only.